Different types of doping causes p-type and n-type materials. In this presentation, I will briefly discuss about doping and p-type and n-type materials. If we observe the periodic table, we can see that semiconductor materials are in group 14. That is, they have 4 outermost orbital electrons. It is a natural tendency of any atom to have 8 outermost orbital electrons, that is the atomic structure of noble gases. In case of semiconductors, all the atoms share their outermost orbital 4 electrons with their neighboring atoms to achieve 8 electrons in the outermost orbit. Pure semiconductors are called intrinsic semiconductors. In intrinsic semiconductors, the electrons grab thermal energy from the surroundings and get rid of bonding. These electrons are said to be in conduction band and they can conduct electricity. As the number of these electrons are very few, the conductivity is not proper. To improve the conductivity, we can either increase the temperature of the surroundings so that more electrons get thermal energy from the surrounding, or we can add some impurity in the pure semiconductor. The process of adding impurity is called doping. Doping is of two types. We can either add pentavalent impurity like phosphorus, which causes excess electrons in the material. The material is called n-type material. Or we can add trivalent impurity like boron, which causes excess holes in the material. The material is called p-type material. So we can define semiconductors as materials that have conductivity in between conductors and insulators, negative temperature coefficient for resistance, that is, if the temperature increases, resistivity decreases or conductivity increases, and improved conductivity if doped. Elements like silicon and germanium show the above properties and are called elementary semiconductors. Compounds like gallium arsenide, indium phosphide, gallium nitride also show the above properties and are called compound semiconductors. This is all for this presentation. See you all in the next one.